Alrighty, so hello everyone. Today is the final workshop of the semester, which is the Raspberry Pi setup and the virtual server. I'm Chris Lai. I'm the president of Cal Poly Pomona Hyperloop, and this workshop is a collaboration between IEEE and CPP Robotics. We'll be covering a bunch of skills today, including the Raspberry Pi setup, which will include the wired setup, talking about the wired setup with the keyboard, mouse, and a monitor. The headless setup, which is much more convenient. And with it, we'll be using a lot of different softwares to achieve this goal, including the Imager, advanced IP scanner, our SSH clients such as PuTTY and WinSCP, and the remote desktop as well. So there's a lot to cover today, so let's get started. We'll also be covering the virtual server, by the way. So along with the Raspberry Pi, which is a little physical device you have in your home, you'll also be able to purchase some virtual servers that may be online. So here I'm going to cover Linode, but there's also Amazon AWS and also, I think of another one, the Microsoft Azure. So if you're in CS, you might know some of these as popular hosting sites. And we'll also cover some basic Linux commands, data transfer, and then maybe if we have time at the end, we'll talk about setting up a microserver because that's pretty fun topic to talk about. Okay, so HDMI setup. In order to set up a Raspberry Pi, a lot of introduction tutorials tell you to set this up using HDMI with a separate monitor. So you have a separate monitor in which you plug the Raspberry Pi into, and then you plug in a keyboard and you plug in a mouse, and from there you can set up the Raspberry Pi and do things with it. It's actually the first time I used the Raspberry Pi, I set it up this way, and it's a lot. You know, you have to have your USB keyboard, USB mouse, you have to plug in your power, you have to plug in your SD card, you have to plug in your Ethernet. If you have Ethernet, you plug in your monitors. It's a lot of stuff, right? And so I'm not going to cover too much into it. You guys got to plug all the stuff in and it turns on, you set it up from there. But mostly we're going to talk about the pros and cons of it. By the way, this is a Raspberry Pi 400, I think. It's the keyboard. They put the computer inside of the keyboard, so all you need to do is plug in the mouse and then plug in the monitor, and then you'll have your computer. That's all stored inside what you type in, which is really nice. This is one of the newer models, right? But the pros is that it's a simple setup procedure. It almost works every single time unless you have a faulty HDMI cable or a faulty HDMI setup connection in which you need to reflash your SD card. It's used widely as such in the 400 keyboard. It's a guaranteed method. Now, I'm saying here it's guaranteed, but you know that's not really that guaranteed. It's guaranteed if you know how to set up the micro SD card correctly, and then we'll talk about that a little later on. And it's a time saver. This saves time if you have all the resources. You know, setting up the micro SD card using headless may take some time, may take some bashings of the head against the wall, but eventually it does. Well, we do get there. Approximately, I would say that if this method is a time saver for beginners, but if you're advanced at setting up multiple Raspberry Pis, you want to go with definitely the headless way because you don't want to go ahead and lug around a monitor wherever you go. You just want to like bring a hotspot maybe, and then bring your Raspberry Pi that's already like connected to the hotspot so that you can access your files from anywhere. So it's like a cool little, fancy little computer, like pocket computer. The cons is that, of course, it's a price concern and a resource concern. This requires a lot of resources for it to be able to run because, again, you need to lug a computer, like a monitor and a keyboard and a mouse everywhere you go. And even that, it's like not the best of quality if you try to like do anything on the monitor itself because it's a computer, but it's very small and therefore doesn't have much capability to like do things. So even dragging a monitor across the screen, if you don't have enough RAM, it gets very laggy very quickly. Aside from that, if you try to get into it using command prompt, it's much faster and much easier. And you just need your computer to do that. You don't need like a separate monitor. So let's do a headless setup. All right. Now I just copy pasted this slides from like one of these presentations I did last year for the ECE team at Cal Poly Pomona Hyperloop. But the micro SD card, or step one is the micro SD card, but basically A headless setup means that we're going to set up the Raspberry Pi without it ever being connected to a monitor. And that originates from the micro SD card itself. See, the micro SD card is the brains of the Raspberry Pi. In here, the micro SD rests in this slot. I will show it on camera, but it's on the top slot usually. And we plug in the micro SD card there in order to give the circuit board instructions on what to do, right? So that means you can transfer, you can do some brain transfers of Raspberry Pis if you have multiple of them, and you can just take the micro SD card out of one of the Raspberry Pis, plug it into the other, and it'll work exactly the same. Just the difference would be processing power in case you like just change different processing powers. But mostly it should work the same unless you have some like really high speed program working on there and you put it onto Raspberry Pi Zero, then there'll be some difference, but I digress. So this first step is to set up the micro SD card. We're going to insert the micro SD card and the SD card into the PC. We're going to open up Raspberry Pi imaging software. By the way, I should probably share this PowerPoint with you guys. I'll do that in the description. There's only Addie here, so I'm going to just share this with Addie so you can like follow along. In a second.
Thanks.
I did put all the links here. Share this again. So the Raspberry Pi imaging software is an open source image flasher. Now, what does that mean? You're flashing an OS to a SD card. We're putting an entire operating system, that's what OS stands for, into an SD card so you can program the device, right? So we're going to image the card using the Raspbian 32-bit OS. Now, let me go ahead and switch my screen here to show you what that looks like. I'm going to be doing this a lot. Okay, so here I have Raspberry Pi Imager 1.6.2. Usually what you do is you choose your OS and you choose Raspberry Pi OS 32-bit here. And then you choose your storage, your mass storage device, and then you write it. Now, make sure that you remember that when you write the files to the device, it'll erase all the content that's currently on it. And sometimes, you know, this happens. Like you have to erase, you have to like, take a sacrifice in case you break something accidentally. Just do a fresh restart. You're pretty much putting a new OS inside your computer. So this is the first step in writing your micro SD card. I now realize how inefficient this process is, but it's fine. Okay, so once you have it flashed, this comes the most difficult part of the entire thing. All right, you want to navigate into the micro SD card directory and create a file with no extension called SSH. Now, most Windows computers will see this and will say, "Hey, wait a minute, that file has no extension. That's going to be very that file is going to be very unstable, but that's all right, right? We want the file called SSH to be there so that when we put it into our Raspberry Pi, it knows to activate the SSH protocol so that we can access it through a computer later, right? So we want to create a file with no extension called SSH and put it inside the directory. Next, we want to create a file called WPA_supplicant.conf. .conf is the file extension. So make sure you are able to change this file extension. I'll show you how to do that later. And you want to paste the following code into it. Now, the following code will tell the Raspberry Pi which internet connection to connect to. And it must be correct because you can't change this later. If you go ahead and like accidentally type something wrong for the username or password and you plug it in, these SSH and WPA files will disappear after the Raspberry Pi has run them for the first time. Because there's already like, it's a way to program the instructions to the Raspberry Pi, like through the SD card. That's what you want to watch out for. If you mess this part up, then you have to like restart the entire process again. You want to replace the SSID and password with a Wi-Fi username and password. That's simple enough. Make sure you keep the quotation marks around it. So let's go ahead and do that. I have my Raspberry Pi, one of my SD cards ready to set up here. So I can go ahead and show you guys how it's done. Okay. Okay, inside my boot drive here, we can see that we have a lot of different files. Now, this is the files to a little small micro SD card I just flashed with Raspbian 32-bit. Now, what we do here is, just in case you don't have the file extensions, we're going to go to View, and then on the Show Hide bar here, we have file name extensions and hidden items. Check both of them. Next, you want to go ahead and right-click, go over to New, go over to Folder, or no, not Folder, Text Document, and then create a new text document. Now, you should be able to edit the file extensions in this part of the process here. You're going to type SSH, and it's going to say, if you change the file name extension, the file might become unstable. Are you sure you want to change it? I don't know if you can see this, but let me see. You can't see this, but let me show you. So here it says, if you change the file name extension, the file might become unstable. Just click yes, because you know what you're doing. This is not going to go into your computer, but go into the Raspberry Pi. Next, I want to go ahead and create a text document. And in this text document, I want to rename this to WPA_supplicant.conf. And again, it's going to say it's unstable, but just click yes. And open it with Notepad. Now, here's my Notepad file. This is similar to a text document here. I'm just going to go ahead and go back to this slide and copy all of this stuff in here and paste it directly into this thing. Now, I'm going to go ahead and place my Wi-Fi SSD and my password in here, but just trust me on this, that I have done this correctly. So type that in. So I've typed in my Wi-Fi username and password. And now we see we have our two extra files. We have our SSH and we have WP_supplicant.conf. All right. Now I'm going to go ahead and eject this now because I'm done with this file. And we can move on. All right. Now I'm going to take my USB drive. By the way, this is a USB to micro SD card converter. You just insert it onto the top here. This comes with like any Raspberry Pi kit. And then you can insert this into your Raspberry Pi Zero. Now here, I'm going to insert this right now. And with any luck, it should read the card successfully. But with my luck, it never happens first try. So, okay, Raspberry Pi Zero has been inserted with the SD card. I have a power bank here that I usually use to power my Raspberry Pi 4. Now, this is a huge power bank. Normal power banks may not work to power a Raspberry Pi. Remember, it's like using a power bank to power your computer. It's not going to work, right? So you need a bigger one, a more chunkier one like this one. I believe this has an output of about 3.4 amps max based on USB 5 volt. And it has about 30,000 milliamp hours of a capacity. So it's pretty good for a battery. So I'm going to use this and plug this into my devices, and I'm going to see if I can get any signals. So I'll plug this into power. Now, as a backup, I do have my Raspberry Pi 4 here from Cal Poly Hyperloop that I'm also going to plug it in just so you can see that thing being successful. So the next step in our presentation is finding the Raspberry Pi's IP address. Now, this used to be a very difficult process as you don't know where the IP address is. There are two methods. You want to first power up the Raspberry Pi using the provided charging cube, or you can use power bank, or you can use some other method. But some other method is going to be kind of questionable if you don't know what you're doing. So for portable, it's like just power it with the given charging cable. The Raspberry Pi is ready when the green light stops flashing. Now, what does this mean? The green light on the Raspberry Pi is the activity light. That means that on the Raspberry Pi, the activity light will like start flashing and stuff. If it continues to flash, that means there's something wrong. The normal behavior of a Raspberry Pi's green light blinking, it'll flicker a bunch of times, and it'll increase its speed of flickering, and then it'll suddenly just like die down to a halt. Now, I know the behavior of this, and for the Raspberry Pi 4, that's the behavior. For the green Raspberry Pi, I can see here Oh, this is actually interesting. I may have encountered a setup mistake if I'm not correct. So I'll show you this. If the green light stops flashing, that means it's successful. But if the activity light does something like this, so I have it plugged in here, and I don't know if you can see that, but the green light is blinking. If it's blinking on and off, that means it can't read the SD card. Now that may mean that, oh, it just stopped blinking. Okay, so my Raspberry Pi Zero stopped blinking, which means that it successfully read the SD card and now is ready for access. So from what I know, it's just like if it keeps blinking on and off in a continuous pattern, that means it can't read the SD card and something went wrong. You need to like reflash it. Okay. Now there are multiple ways to find the IP address. One is using ARP-A or ARP-A in the command prompt. Now sometimes this works, sometimes this doesn't work, because sometimes the IP addresses are hidden from you. We have dynamic and static IP addresses here. Static IP addresses are sensitive, so make sure you don't show them ever. And usually the Raspberry Pi's address will be the second to last dynamic address. Now, why is this? Usually what happens is you have the local ports from zero for the last 3 digits of these addresses here are usually for the port. And in a, let me just go back and check here. Okay, I have my cursor now. So the last 3 digits are ports. Usually you have from port 1 to port 254. When new Raspberry Pi enters the EB network, it'll get assigned a random IP address, a local IP address. Unless you specify it having a static IP address, this is just going to choose at random. Usually it's going to be like a greater number, you know, and on the IP address, you can think of it as going from like oldest to newest connections. And sometimes this works, sometimes this doesn't. As for I've seen in like helping some of the Hyperloop members set their Raspberry Pis up. So there's a more guaranteed way to do so. If you know how to access your Wi-Fi distributor or like the app where it shows you all the IP connections connected to your Wi-Fi right now, you can go ahead and look at that app and it'll directly tell you which port the Raspberry Pis are connected to. But sometimes people don't have that. Maybe it's because their guardians or parents are having that app locked down, or it's blocked by some service providers. But usually you have access to that app and you can directly check it from there. However, if you don't have that or you're too lazy to get out of your seat, I have a solution for you. So Advanced IP Scanner is a very good application where you can scan all the IP ports directly from your computer. Now, there's a good and bad side to this, of course. That means the good side is that it's easy, right? It's easy to find the address based on this application. The bad side is that sometimes it's hidden again. Sometimes the IPs are hidden from you, but I haven't had that happen to me yet regarding like my home. So it should be fine. But if you run this and you only see like one thing pop up, that means that something has not worked. You can click the download link to download this application, but I'll show you how to use it in a bit. Okay, so this is Advanced IP Scanner right here. So this is Advanced IP Scanner. When you press scan, it'll go through every one of our IPs and search for our devices, right? And it'll just run through its course. We can see that, okay. We can see that our Raspberry Pi Zero has the name Raspberry Pi.home, right? Now, this is the default name for a Raspberry Pi. You can change it, of course, in sudo raspi config. You can give it a fun name, so it appears on your network differently. But the Raspberry Pi.home is the default. So we know that it's attached to port 61. I'm going to just point out some other devices you can see that are on my network. Right here is my MSI.home. This is the computer that I'm working on right now, right? It's on port 57. Here we have an ESP82 ECF7. Now this is interesting. I have a home server set up somewhere else where it controls my Alexa sync, right? We went over this last time. It's an ESP32 connection, but on here, its address is ESP82. It's a connected on port 19, which means that it is a pretty old connection since it's earlier on the list. We remember that these things don't have static IP addresses. So if my IP or if my Wi-Fi network resets, all of these may reset. So, but my Wi-Fi hasn't reset in a long time. That's why I know that this is like the earlier numbers are usually older. Here's my Lenovo laptop. That's my other laptop I have beside me. It's just fun pointing out things. This is my Raspberry Pi for another project. And oh yeah, that's also my backup Pi that I've plugged into my device here. So we have two Raspberry Pis that are currently online and my ESP32 home sensor. So we know that if we SSH into 61 or 39, we're going to get something, or we're going to get a result. And we'll talk about SSH in a little bit, but just remember that 192.168.254.61 is where our Raspberry Pi is located at right now. You know, I actually tested this beforehand and it didn't work. So I'm like genuinely surprised that it actually started to work now. Okay. The next step is to ping the Raspberry Pi to test for connectivity. In the command prompt, type in the command ping and then the Raspberry Pi IP after it. If you see this happening on a ping command output and you see replies, that means that there's something on that terminal, there's something on that port. And then you're going to SSH into it. Now, SSH stands for Secure Shell Connection. I think I got that correct. Now, Secure Shell allows you to access another device based on your network from your own command prompt. So we can use SSH Pi and then add the Raspberry Pi IP address to link the PC with the Raspberry Pi. Okay. Now, this is your first time accessing the Raspberry Pi through SSH. It'll prompt you to add a new password. Now, the thing about Raspberry Pis and their security is that they are extremely easy to hack. If you go to any public place, let's say I do this presentation at Starbucks, right? And Starbucks' internet is not very secure. People hack into other computers there all the time. And this is the same thing. It's like I can hack into my Raspberry Pi if I know the password, which usually it's default. That means anyone else with the knowledge of how to do so can also hack into my Raspberry Pi. So if I'm trying to run this on like a public server, I have to be extremely careful because there's like absolutely no protection. There's no two-factor authentication. It's just a simple login and activation of the Raspberry Pi. That's why usually Raspberry Pi's memories, you don't want to store any critical information inside of there. The memory can be wiped at any time, and usually as developers, we do this all the time as well. So a physical hardware device may not be enough security because people can breach into it through your local network. And if your Raspberry Pi accesses the internet, that's even a greater security risk. But unless you're getting cyber security, if you're just learning this as an introduction to Raspberry Pi, you don't have to worry about that. You only have to worry about actually getting access to it. So let's get access to it. I know that most of you guys, I don't know if you have your Raspberry Pi right now or if you guys are just looking for information, but I also do like coming back to these presentations later on just to check about how to do things, because I may know how to do it now, but I may not know how to do it in the future. So it's good to know. Okay. So here is my command prompt. You guys can open a new command prompt when you have Pi, and you want to go ahead and type in SSH Pi and then our IP address was 192.168.254.61, right? The first 9 digits will always be the same based on your IP network, but the last 2 digits are different because they're the port. And we found out that the port before was 61. So I'm going to press enter, and it's going to say the authenticity of host can't be established. The ESDCA fingerprint is that. Are you sure you want to continue connecting? We're going to say yes. It's going to permanently add it to the list of known hosts. Now, this is important. If you have multiple Raspberry Pis and they connect to the same port, so for example, if I turn on my third Raspberry Pi and it connects to 61, it's not going to be able to because it already has this as memory. Even if I turn my Raspberry Pi 0 off, and 61 is still binded to that device. So if another device tries connecting to 61, the terminal will not let it. There is a way around this. And if you run into this problem, just message me, because you have to go into your file directories, find your .ssh files, and delete that ESDCA fingerprint on it. ESDCA, yeah, ESDSA, sorry. So that fingerprint is on there for this device only. It's like a human fingerprint, except for a hardware device. Now, the password by default is Raspberry, so RASPBERRY. You will notice that when you type in your password, you will not be able to see it in the terminal window. I think I messed that up, actually. Oh, just kidding, I didn't. It says that SSH is enabled. I'm going to zoom in on this so you guys can see. SSH is enabled, and the default password for the Pi user has not been changed. This is a security risk. Please log in as the Pi user and type password to set a new password. So if you're using a Pi, I highly suggest you do this, but just keep in mind what the password actually is. If you forget, you're going to have to restart the entire thing. There is a method around that, but it's a little difficult. But my point being is you don't want to have like permanent file stored on the Raspberry Pi. It's not a good life choice, I would say. All right, what's next on our PowerPoint? This point I'm just going to keep going back and forth with it. It's right here anyways. The next step is to connect the Raspberry Pi through the SSH network protocol after the restart, blah, blah, blah. And this is remote desktop. So if you want to go ahead and do this, you can follow these two slides. It's just accessing the remote desktop from your Raspberry Pi. But if you have a Raspberry Pi with too low of a RAM, like 1 GB is already very, very laggy. So I suggest you don't do this unless you have a tank of a Raspberry Pi, like an 8 GB one, then go ahead. But I'm not going to cover these slides 11 and 12 because you guys can do this on your own. And if you have questions, you can always just go ahead and message me on Discord or email me or whatever might be the case. All right. That's 2:30. I have such impeccable timing. I'm kidding. We're going to start covering Linode now. All right. So Linode is our virtual server. And virtual server is pretty much a computer that's not physical, but it's like in another place. Like right here on the right here, we have a virtual server in Fremont, California. So there are these places in the world where it's just like a building full of computers. Now, people like me and people like you maybe will go ahead and buy like or rent space. It's like renting an apartment, except you're renting a computer that's inside of this building. And you can use this computer as long as you pay for the fees, right? And usually it's not that expensive. I think it's like $5 a month for like a 1 GB RAM. The Hyperloop server right now is $5 a month, but we are upgrading it soon to allocate for more space, just in case we're running more memory heavy dependent files, you know? So we can see data on the right here. This is what the server looks like once you actually buy it. You can access it through SSH again, right? It's the same way as the Raspberry Pi, except that this computer is not in your house, but it's in another place. So it's better to access it, you know, if you're accessing like a web server or if you're using it as a server. Using it as a server is the best way to use a virtual server, obviously. But if you're trying to use a Raspberry Pi as a home server and like people from other places are trying to access the server on your Raspberry Pi, they're going to have to access your network or your Wi-Fi, or that's a security breach, right? And so using a virtual server will allow for you to overcome the security breach, and you just get general protection overall. You can store data on this thing. You can have website/server hosting, and that's completely fine. But just remember to back your stuff up. And we'll talk about how to do that later using WinSCP, the file transfer service, because you have to remember that these devices can easily be erased. So they're easily erasable than your own computer. So you always want to make sure that all your data is backed up somewhere. And the somewhere can be your own computer on a USB drive or whatever the case might be, right? And if you guys want to try it out, you can use the referral link down below. This is actually my referral link. So you get $100 of free credit to try out whatever you want. So you can actually go ahead and, you know, start your own Minecraft server for a month or 2 months. And then $100 is enough to cover like a full 8 GB Linode. So you can go ahead and have fun with that. But if you would like to continue using Linode using this code, I think the deal is like I get $25 of credit on Linode. I don't know, but it's mutually beneficial. Point being. Okay, this is important. PuTTY and WinSCP. PuTTY is our SSH client. We covered how to access the Raspberry Pi through SSH. We can actually access the Linode through SSH as well. Oh, I should probably cover how Linode looks like, before I do that. But PuTTY and WinSCP, the download links are here. You can download them beforehand. And then I'll cover Linode in a little bit. Or actually, not in a little bit. I'm going to cover it right now. All right. So this is what Linode looks like. Let's just like create a mock Linode, right? So here's what you're looking for when you create a virtual server. Now, remember, you're buying a computer here, right? So just have in mind you're buying a computer that you can access from your own computer. It's like buying a temporary thing for now. I can't think of a good analogy, but I'm sure someone out there will have a good analogy for it. Okay, our distribution, you can use any distribution, CentOS, you can use Debian, you can use Fedora, you can use Gentoo, Rocky, Slackware, Ubuntu, and OpenSUSE. But I like using Ubuntu, and the latest version of Ubuntu right now is 21.10. Now, Ubuntu is a Linux-based OS, which is really cool. You can use Ubuntu on Raspberry Pi as well, but the setup is just a little bit different. It's not the same as the Raspberry Pi Imager, so just watch out for that. I'm going to select a region, and I'm going to choose Fremont, California. Now, here's the advice for the selection of the region. All right. If you're hosting like a game server, let's say a Minecraft server, where your players are going to be from across the country, you're going to want to try to find the median of where everyone is and put the server there to equalize the ping for everyone around. However, if everyone is like inside California, and because Hyperloop is in California, we're going to choose the closest area, which is Fremont. The ping, average ping, and we've done a calculation for this, between this place, Fremont, California, and to another person's computer is about 20 milliseconds, which is not bad. 20 ms of ping in like, I don't know, some game like League of Legends is amazing, right? Unless you have a beefy computer. Okay, for a Linode plan, we're going to click shared CPU. And of course, shared CPU is going to be cheaper than our dedicated CPU. It's like going to a hotel room and saying, I want to share a room with 4 other people, rather than share a room by myself, or dorming with 4 other people rather than dorming by yourself, which is the more expensive option. You can obviously tell. So we're going to click shared CPU to save money. Usually we want a Nanode 1 GB. It's $5 a month, less than a cent hourly, so it's good, but only 1 GB of RAM. So not good. You have 1 CPU and a storage of 25 GB. By the way, you can access these virtual computers through remote desktop as well. So if you go through slides 11 and 12, you follow the steps down remote desktop, you'll be able to access the virtual server through that method as well. Okay, so just the cheapest one's fine for now. We're not doing anything too resource heavy. And this Linode label, we're going to give it a name like test. I'm not actually going to purchase this. I'm just going to do this for show, just in case you want to set one up yourself. And you're going to enter a root password. Now, this password is important because it's the password that you're going to use to log into the Linode, right? SSH keys, you can just ignore that. VLAN, you can ignore that. Add-ons, you can ignore that. When you create the Linode, Linode as a company is going to do all the setup for you. It's going to make everything nice and neat and do all the flashing and all the stuff. It's going to make a new space for you in their servers. And then after a few minutes, it'll be ready. And so if I go to my Linodes and click on Hyperloop, we can see that the IP address of this server is 173.255.223.231. And to access it, we do SSH root at this address. Now, if I copy this and paste this into, I'm going to exit out of this command prompt here and create a new one. Command prompts are very useful. Okay. And I go ahead and type in that. And it's going to say it can't be established. Do you want to continue? I'm going to say yes. And my password for this is, wait, this is the Hyperloop server. So my password is that. Now you can't see the password, of course, but just showing you that it works in SSH as well. So this is system restart required. This is on, oh, it shows my IP address. Don't DDoS me, everyone. But I'm going to go ahead and type ls to show that we can have files inside here. We'll go over the essential Linux commands later on. Okay. Also, this specific tutorial will be unlisted because security reasons, but just watch out when exposing your IP address to everyone else, because there is chance for it to be DDoSed, and you don't want that. You have to change your IP address. It's not going to be fun for the family. Okay, I'm going to close this and return to the PowerPoint. So you can access your Linode through SSH through the command prompt, as we've shown, but another good way to access it is through PuTTY. Now, PuTTY is your SSH and Telnet client for Windows. It's pretty much like Visual Studio Code instead of compared to Notepad. You know, Notepad is like good and all. It's comparable to your command prompt, but PuTTY is like Visual Studio Code. So I'm going to boot up PuTTY so you can see this. And PuTTY configuration kind of looks like this, right? We'll go ahead and SSH into CPP Hyperloop. I'm going to load this thing, and we can see that we have the host name here. We have our save sessions name, which is CPP Hyperloop. And here I've actually modified the appearance of it. You can actually make your thing look really pretty. If I click on appearance, you can see I changed the font to Courier New, and I changed the font to 18 point, just so I can see things better, you know? By default, I think it's 10 point, and so that's like way too small. I can't see that thing. So in my session, we can see that our data is inside. Therefore, we can open this. And then when I click open, I see this window pop up. You won't see this window pop up if you're doing this for the first time. It'll ask you to like verify the fingerprint and everything. It's going to do all the ESDSA stuff again. Just click yes, yes, yes. And then you can log in as root. Now, this is your password, right? When you created a new Linode, you have to put in a root password, and this is what it is. So I know for Hyperloop, this. Cool. And we have access to this. So this is our virtual server, and we can access this server by through PuTTY. I'm saving the commands to till later, just so I can explain them all at the same time. And we also have WinSCP. So how do we get files onto our virtual computer? There are two main ways. One, through GitHub, right? So we can put files onto GitHub, and then we can do a git clone into our PuTTY, and git clone just copies the files from the GitHub and then pulls them into your directories. And it's really cool. Now, if you guys have worked with Git before, Git actually came up with a new authentication system that requires you to have SSH keys in your account before pulling from the web. And now SSH keys take a while to set up, so you can go look that up on github.com, but you do need an SSH key in order to get files like now during the present day. So it's kind of like two-factor authentication, but for account. Okay, I'm talking way too fast. Give me a moment. Okay, the second way is through WinSCP. So WinSCP is an SSH file transfer service. Now, what this means is that it can take files from your computer, and then it can put them onto the server. Now, WinSCP works with both the virtual server and your Raspberry Pi. So you can take files from your computer and you can put it on your Raspberry Pi as well. It's a really cool way how it does that. So we're going to go ahead and use WinSCP to just check the files between our computer and in the virtual server. So if you download WinSCP, you should be able to see that it kind of looks like this looking thing. Oh. Kind of looks like this, right? And I have CPP Hyperloop. I'm going to go ahead and log in and then use my username. My username is root for the virtual server, and then it's going to be pi for the Raspberry Pi. Authenticate. So, okay. Now I've logged into WinSCP, and I can see that on the left bar here is the files that are on my computer. On the right bar here are the files that are on my server. Now we can see here that I have 4 folders. I have CPP Hyperloop, a term project, the Hyperloop bot, and Snap. If I go into the localhost, I'll give you guys one command now. You can use ls, which stands for list, to check how many folders or what's inside that current directory. Now, the directory path is given by what's over here on the left. So root at localhost, that's the root folder. And we can say in the root folder, there's 4 different folders. And the names are matching, right? You have CPP Hyperloop here, and we have CPP Hyperloop here. Now I'm going to go ahead and drag a random file into this into the folder here. Let's drag the readme.md. Why not? Okay. By dragging, I have copied the file into the virtual server. So on the right here, now we have a readme.md in the root directory. So I can go ahead and run ls again, and you can see it immediately changes because, again, I'm uploading to the server, and I'm accessing it from 2 points, right? One point is from the WinSCP. The second point is from the root at localhost. So I see my readmd here, readme.md, and I know I've succeeded because now the file is in the virtual server, right? So you can do this for the virtual server and for your Raspberry Pi. Again, you just need to log in from different places, and you need to make sure that your username and password are carried along the way. Remember, there's no 2-factor authentication, so these things are not that secure. You don't want to store any permanent files on here, and make sure you have constant backups. Backups are really easy. Just make sure you select the folder that you want to back up and drag it back into your own directory. Like, let's say I want to save this Hyperloop bot, right? I can drag this back into my main computer, and now I have a folder called Hyperloop bot inside CPP Hyperloop, and it contains the same files. I'm just going to delete this because I don't need it. But here, this is like on the screen in front of you, how we can transfer files to a server that's not actually in my house, but somewhere like miles and miles and miles away. I just find it really cool. Okay, what's next on our slides? Oh, cool, we're here. So essential Linux commands part 1. These are just a few of the Linux commands that I use the most, right? I have 2 slides of this, 1 and 2, but the Linux commands on 1 are, I think, what's are agreeable that they're the most used and they're the most common. So our first is cd, which stands for change directory, right? So cd directory, I'll go in here and do an example with the CPP Hyperloop folder. So I'm going to do cd and then CPP Hyperloop. A shortcut you can do is you can type the first 2 letters like CP and then press tab and it'll fill in the rest for you. And so tab will just autofill. Tab is autofill in Linux, right? Another shortcut is to right click. Right click is to paste, right? Right click is to paste. It's weird because Control V doesn't really work. Control is a control character, which means that if you try to do Control C, Control V, the Linux terminal will think you're doing something else. So right click is to paste, tab is to autofill, and then the third command that's really useful is the up arrow. The up and down arrow scrolls between your previously used commands. So you're trying to run a really long command and you messed up and you accidentally hit enter. You can just press up to get it back again. Again, up and down cycles through commands, the up and down arrow keys. Again, really useful things, right? So now if I type ls, I think our next command is ls. I'm going to go with ls first. I'm going to actually put the PowerPoint on the left here. Present review. Okay, like that. Okay, so I have, we went over cd. Now cd on its own returns to the root directory. So if you type cd with nothing after it, it goes back to the root directory. Right? And then cd ... goes back 1 level of a directory. So in here, in the current directory, we can see we have official release folder and a previous versions folder. I'm going to cd into the official release folder. Oops, ls, lowercase. And in order to get back to the previous directory, we just do cd space period. And now you can see that the address went from official release back to CPP Hyperloop. Now, again, you want to get into the habit of typing ls because it tells you what's actually inside the current directory. You want to keep a mental image of where you are in the computer so you don't get lost, because it's really easy to get lost in a computer like this. It's not a interface you can just like look at it on a monitor. It's actually just command lines, right? So you got to make sure you run ls constantly just to know where you are. Now the next thing is mkdir. So I'm going to go back into the main directory, and mkdir makes the directory, right? mk is make, dir is directory. So I'm going to do mkdir. Okay, here's the thing. mkdir, the rmrf and apt-get install all need sudo. So sometimes what it'll scream at you to not do is like, let's say I do mkdir and then I do test folder. I can see that a new directory has popped up called test folder, but sometimes this won't happen because it needs admin privileges. So that moves us on to the next one, which is sudo. Sudo is called super user do, su do, right? This runs the command as an administrator because sometimes it doesn't think you're an administrator, so you have to use sudo to run it. And so just using sudo means like you're at the highest level of control of the server, and the server will just do whatever you say, which is useful when we do rm-rf directory. Now rm is remove, so it must use sudo just so you don't mess up. I'm going to do rm-rf without it just to see if my server actually has the permission, and I'm going to do test folder. Now rm-rf completely removes the directory. Usually it requires sudo, with -r meaning recursive action, so it's going to do a recursive loop to remove everything in the folder and the folder itself, and -f means force. So -rf means recursive force. All right. So doing rm-rf test folder, did that work? Oh, that actually worked. Okay. But this usually requires sudo. Because this is a virtual server, the permissions aren't that great, which is why I'm telling you about security and the issues that virtual servers have with general security. But in this case, rm-rf worked without the sudo. So, but if you're trying to do this in your computer, like your Windows computer, it'll allow you to do so. Okay, and lastly, we have apt-get install package. Now, apt means advanced package tool, and this function just installs packages. You can use sudo apt-get install npm, which is node. You can use apt-get install upgrade, apt-get install update. You know, those things are really common. If you're installing remote desktop, you've already run sudo apt-get install xrdp, which is like the Windows server for your Raspberry Pi. Now remember, these are Linux commands. So Ubuntu is a Linux-based computer. The Raspberry Pi is also a Linux-based computer. So it's able to run these commands along with your essential Linux regular thing. But the Raspberry Pi does have some separate issues to deal with, you know. So we'll go over that real quick. So this is something that's mainly directed towards the Raspberry Pi, but some of these do work for the Linux server as well. Something like Python 3 and running a file name runs a Python script. You can use nano to open a file .text or .py for editing purposes. And the last three, the next two are just for the Raspberry Pi. So let me go ahead and boot that one up real quick. Now, this is just my personal preference, right? But I like using command prompt for SSHing into a Raspberry Pi, and I like using PuTTY to SSH into a virtual server. The reason is because sometimes the static IP address of the Raspberry Pi will change, and because it's changing, I don't want to accidentally have to like redo my settings and everything. So I use SSH in the command prompt to do that. So SSH pi at 192.168.254.39. All right, no, it was 61, right? I would like to take a moment to note the enormous amount of delay happening on the screen right now as it tries to log in. Oh, I'm done. Just realized I haven't put in the password yet. Okay, yeah. When you've worked with Raspberry Pis a lot, you'll know that this is like extremely slow. Because this is a Raspberry Pi Zero. These are like the cheap $10 ones. They're good, but they're good and cheap. So they're good quality. But there's always better ones, you know. Okay. Now we're going to go ahead and talk about some safety with the Raspberry Pi. So let me see, ls, if I do ls, there's actually nothing in here right now. Oh, it's just lagging a bit. But again, Python 3 file name activates the Python script. Nano, I won't show right now because of time, but this actually just opens a file for editing purposes. So you want to edit a file inside the Raspberry Pi, you have to use Nano. If you want to shut down a Nano, this is a very important part. You use sudo shutdown now. This is the safest way to shut down a Raspberry Pi. Now, be careful when using this. You don't want to immediately pull out the plug for power after you run sudo shutdown now. When you run this command, so sudo shutdown now, when you run this command, what it does is it saves everything in the Raspberry Pi and then safely shuts it down. If you pull out the plug during this process, you have the chance of corrupting the SD card. And that's not good because you have to start the entire process over again of reflashing another OS into the card and doing all that good stuff, you know. So when you type this in, you'll see the green light start flashing again. Now, you know it's safe to pull out the power when the green light stops flashing. This is usually going to take around 30 to 50 seconds. So just a word of warning, you know. Before I do that, though, I'm going to go ahead and rename my Raspberry Pi 0. I'm going to go into sudo raspberry config. This is like the settings and preferences menu for Raspberry Pi. So sudo raspberry config. And it'll bring up this cool little menu. All right, it's like the preferences menu. Now, there's a lot of stuff you can do here. Let's say system options. I can go ahead and change the password. I can change the host name. The host name is actually pretty interesting, right? You can change the name that this thing will show on Advanced IP Scanner. Instead of Raspberry Pi, I'm going to change it to RPi Setup Workshop. And then the next time it'll boot, it'll go ahead and show that on the network. So I'm not going to reboot now, but I'm going to show you that we have sudo shutdown now as an option. So I'm going to go ahead and safely shut down my Raspberry Pi at this moment. So sudo shutdown now. All right. Now I'm going to bring this up here so you can see this light, but I'm going to go ahead and shut down the Raspberry Pi. Just note the green light in the corner. All right. Oh, I spelled it wrong. Shut down now. Oh, did that not work? Okay, no, just kidding, it worked. It's just slowly shutting down. Because remember, the Raspberry Pi 0 is it's way slower than the Raspberry Pi 4. So I don't know how well that shows on camera, probably not well because of the green screen, but the light is off. And at this point, it's safe for me to turn the Raspberry Pi off. I don't know why it's just glitching out on the monitor here. Yeah, okay, this command prompt is dead. So now that the light is off on my Raspberry Pi, it's safe for me to unplug it. Okay, so the last fun thing I put on there I want to talk about, but we don't have enough time to get to, is just how to host a Minecraft server. I think the most cool thing you can do with the Linode is just have a Minecraft server with friends. It's a very inexpensive way to play Minecraft, and you can have the server on for 24/7, unless someone overloads it and crashes it. I'm going to show you an example of a Minecraft server I have hosted for my Twitch stream subscribers, actually. I'm going to say yes. Not questions yet, but this is through my PuTTY AN. So again, PuTTY is very, very versatile. I'm going to go ahead and go to this Minecraft here, and I'm going to log in as root. I'm going to say root password as different password. Okay, so ls, I have this folder here. Now, we're not going to get into the more complex things about servers, but I'm going to use a command here called screen. And screen is going to tell me which connections I have. So I believe it's 803. So if we go screen -return 803 Minecraft, it says that, oh, this is, oh, that's interesting. Someone random joined the server and they weren't whitelisted. But this is like the data log of what's going on in the server right now. Every single action happens in this data log. So I can go ahead and Control AD out of this, and I'll show you what the data files look like. So Minecraft is based on Java. So you need some version of Java Oracle in order to run it. And of course, that'll take some Googling, but eventually what you have is something like this, and you have the server.jar file. And then you just run it using Java and then all this data afterwards. So this command -xmx4096m just allocates 4 GB of memory to the Minecraft server. And then -jar server.jar no GUI just activates, tells it which file to look at, and then activates it with no GUI, right? So I'm just letting you know that all these commands are possible and that you can go ahead and search up the actual, so Minecraft actually released their own server file, server.jar file, so you can go ahead and download that. Use WinSCP to transfer the file over to your virtual server, and then set up your virtual server with Java and maybe npm if you need it in order to run Java as a command, because Java is not a ordinary command. You actually have to download this. You can see here when I run Java, it's there's a lot of usages for it because it is downloaded through sudo apt-get. So a lot of the skills we learned today are actually applicable to stuff like this. So it's a lot of fun. All right, but I've talked long enough for an hour. So it's currently 3 p.m. I'll open the floor to questions. I mean, it's only added here, but if you have any questions, please let me know. If you have any questions after watching this lecture from the YouTube channels, if you have any questions, just feel free to message me on Discord or email me or whatever might be the case. My inbox is always open. But as of right now, are there any questions? All right. If there's no questions, then y'all are free to go. All right. Thank you, everyone. Thank you, Heidi, for being here.
Thanks.
All right. To those watching on YouTube, thanks for watching, and I'll see you guys next time. Bye-bye.